All right, so starting on section P1 here. So we're going to be graphing functions by plotting points. That's always the one way you can do it. If you don't have a graphing calculator, you can always make an XY chart, plot points. If you do have a graphing calculator, that's a great way to graph functions. You can also, you have to be able to find the X and Y intercepts. We're going to talk about that. And we're going to talk about how we can test for symmetry with respect to each axis and with respect to the origin. So those are our three goals for today. So the first thing, how do we sketch a curve? Now remember, a line is just a special kind of curve. So when I say curve, they might be straight lines too. So one way to do that is to use a table of values, or we can use a graphing calculator. We're going to look at both ways. So first example, sketch the graph of the equation by point plotting. Check your table and graph on the graphing calculator. Describe the viewing window that yields the best representation. All right, so on this one, maybe you already know what this looks like. Does anybody know what kind of shape this is? It is a V shape, yep. What kind of a shift, James? What kind of a shift is it? Actually, it's not. It's with the X. When it's with the X, it's going to be horizontal. And it's going to go to which direction, guys? To the right. So it's going to go to the right 3. So we already know what this looks like. We know it's going to go like a slope of 1. So here's the way it's going to look. If I didn't know that, I could make my XY table. I could plug in 0 for X. That would be 3. I could plug in, -2 for X. That's going to give me -5. So that would give me, absolute value would be 5. I could plug in +2. That's going to give me 1. So I could just plot some points there, but it's much better if I know what this looks like. It's much easier to just graph it quickly. If I did not know, I could always go to the graphing calculator, go to y equals, clear out whatever you've got. To go to absolute value, it's under math, num, ABS, and then I put in x minus 3. I do my zoom 6 to get a standard screen, and right there it is. So they asked us to describe the viewing window that gave us a good result. So my viewing window, I just go to window. I can see I just did this. My X for my viewing window went from -10 to 10 by a scale of 1. And my Y viewing window was also from -10 to 10 with a scale of 1. Okay? You may also be asked for the domain and range. Our domain in this case can be anything, so it's -infinity to infinity. Our range in this case is only from 0 to infinity. We don't have any Y values except for 0 on up. Okay, for the next one, you may not know what this looks like. So let's go ahead and make a table of values. Let's say we don't have a calculator. Well, some easy numbers to plug in for X. I can see plugging in 0 for X would be a good thing to plug in. 16 minus 0 is 16. Square root of 16 is 4. I could plug in 4 for X. The way I know that is because 4 squared is going to be 16. So 16 minus 16 is 0. Square root of that's going to be 0. I could also plug in -4 for X. -4 squared is 16. 16 minus 16 is 0. That's going to be 0 as well. So the way this is going to look is I'm going to have 0, 4, -4, 0, and 4, 0. Looks like this. Bless you. What kind of shape is this then? It's not a complete circle though. The reason it's not a complete circle is because it's not plus or minus in front of it. If you remember from the warm-ups, we got plus or minus in the front, and that's what gave us the full circle. In fact, if I graph this on my calculator, I go to the square root of 16 minus x squared. The good viewing window for this, it might be best to make a square window so that it looks more like a circle. So I can do that zoom square that I talked about a minute ago. Here's what it looks like. I can go to my window and see what that viewing window was. So this viewing window I'm using is about -15 to 15 by 1s. And the Y viewing window I'm using is -10 to 10 by 1s. So when they ask for the viewing window, this is my x min, x max. That's my interval. My y's, I'm saying that's my y min, y max, and that's my interval. So when it says to describe the viewing window that yields the best representation, you do something like that. But there's no definitely correct answer on that. It's just what window did you use. As far as domain and range here, somebody tell me the domain. What is it? Okay, actually I can't test any values though. Like if I test 6 for x, think about it. I would get 16 minus 36, and that's negative 20. Can I take the square root of a negative number? No. So the only x's I can use are in between here and here. Right, so it's going to be from negative 4 to 4. And the range means the y values that I get. So what's the lowest y value that's possible? 0 to 4. Okay. And I can also see on this one, let's talk about symmetry while we're here. This one I can see is symmetric with respect to, see right here, if I fold it over the y-axis, I can just see that symmetry with respect to the y-axis. It's not symmetric with respect to the x-axis because if I fold it over, it's not going to be a graph down there. This one had no symmetry with respect to any axes. It was only symmetric with respect to the line x equals 3. But we won't be checking for that. Okay, intercepts. This is a point where a function crosses the x or y axis. How do we find intercepts? Well, for this one, this was an x-intercept. This was a y-intercept. Look at this point. This point is 3, 0. This point is 0, 3. So how do we find those x and y intercepts? How do we find the x-intercept first? Good. So we plug in 0 for y and solve for x. And I always just think of an example. Like I don't want to memorize that. I just think, okay, here's an x-intercept. What's true there? Well, y is 0. For a y-intercept, what do we do then? Plug in 0 for what, guys? Everyone? X, and then solve for y. So if I want to find intercepts in this example, let's go ahead and find our x-intercept first. To find my x-intercept, I'm going to let 0 equal y. Now, sometimes people say, should I just distribute this? Well, you're not even allowed to distribute it. Anytime I have multiplication, I know that one of these two factors has to be 0, because 0 times anything is 0. So I know that either x minus 1 has to be 0, or the square root of x squared plus 1 must equal 0. And that's because it's multiplication. If it had been addition, if that had been a plus there, then the problem would have been much more difficult. But if it's multiplication, one of those two factors has to be 0. So I can see here, if I solve this, I get x equals 1. If I square both sides, I have x squared plus 1 equals 0. What is that going to be? Is there anything that's going to make that equal 0? Not even negative 1, because what's negative 1 squared? 1, so that's not going to give us 0, is it? The only thing that would really give us 0 is x squared equals negative 1, so x would equal plus or minus I. But lucky for us in calculus, we only work with the real numbers in Calc 1, so we don't even have to think about that. So the only real number that gives us a solution here is going to be 1, 0. Plus, complex numbers don't show up in the real number system when we graph. So that's another reason not to use that. Okay, y-intercept. Now we have to plug in 0 for x. So I'm going to do y equals, wherever I have an x, I'm going to plug in 0. So square root of 1 is just going to be 1. 0 minus 1 is negative 1. Negative 1 times 1, negative 1. So there's going to be our x-intercept and our y-intercept. If I wasn't sure about that, I could graph it on the calculator, take a look at it, and make sure, but we're pretty sure about it. Okay, symmetry tests. For y-axis symmetry, this is going to be true if replacing x by negative x yields an equivalent equation. For x-axis symmetry, this is going to be true if replacing y by negative y yields an equivalent equation. Symmetric with respect to the origin, replacing x by negative x and y by negative y yields an equivalent equation. Now, I've never been a great memorizer, but I can understand things pretty well. If you're like me, I would rather not have to memorize those. I'd rather just understand it. So here's the way I think of y-axis symmetry. To have y-axis symmetry, this point has to turn into this point because it's like I'm folding over that y-axis. So then I just think, what would those points be? Well, this point right here might be, let's say it's 3, 2. If I fold over this axis, then that point's going to be negative 3, 2. So can you see how replacing x with negative x gives me the same answer? So now I don't have to memorize that rule. I can just visualize it. I can think it in my head. Okay, for y-axis symmetry, the x changes. So if x goes to negative x, but I have the same answer for y, then that means that it is symmetric with respect to the y-axis. What about this point if I took it over the x-axis now? Now what would that point be? 3, negative 2. And see what the rule is? Replacing y by negative y yields the equivalent equation. See how that's what it's really doing? And then for the origin, that's this point right here. So if I go over the origin, it would actually go down to here. And this would be over 3 down 2. And so in this case, it's x becomes negative x, y becomes negative y. And so that's kind of like a way you can just memorize it instead of trying to memorize the words. You just think of the pictures. So in this example, it says to show that this graph is symmetric with respect to the origin. Origin, I think of this picture, x goes to negative x, y goes to negative y. So wherever I have a y, I put in a negative y. Wherever I have an x, I put in a negative x. And now I'm going to simplify this and see if it's equivalent to the original function. So this is going to just be negative y. Negative x cubed is negative times positive is negative 2x cubed. Negative times negative is a positive. Well, we're supposed to be showing that this is symmetric with respect to the origin. It doesn't look exactly the same, but why is it actually the same? Yeah. I can multiply this whole thing by any number I want, or I can divide it by any number I want. And so this is going to be y equals 2x cubed minus x, which is the same. So therefore, we've shown it. Questions there? And let's take a look at how that graph looks on the calculator, just to see what that origin symmetry looks like. So I'm going to go back to my original function. Oops. I'm going to do a zoom 6 just to get my standard screen. Here's the way it looks. And can you see how each point is symmetric over the origin? So that's what origin symmetry looks like. Sometimes if I'm taking a quiz and it's with a calculator, I just put them in the calculator and look at them to check for origin symmetry. Okay, so it says to sketch the graph, identify any intercepts, and test for symmetry. So what kind of a function is this? This is one you should just know. Linear. So we have a y-intercept of negative 2. Our slope is negative 1/3, so I go down 1 over 3. Or we can go up 1 and backwards 3. And so here is this line. Okay, we're going to look for any intercepts. So if I plug in 0 for x, that's going to give me a y-intercept. Plug in 0 for x. I can see that y-intercept. For the x-intercept, I can't really see it because my graph isn't perfect. So to find my x-intercept, I'm going to have to plug in 0 for our y. So if I plug in 0 for y, to add my 2, then I'm going to have to multiply by -3. So that's going to give me -6 for x. So that's going to be our x-intercept. And then to test for symmetry, I can just look at this since I've graphed it. Does it have any symmetry with respect to any axes or origin? Nope. Because if I fold over the y-axis, this point would have to go to here and it doesn't. Folding over the x-axis, you can just see that that has no symmetry. If we had to do the domain and range, let's just do that. We can use anything. All right, and then on example 2, does anyone know what kind of shape this is if we have y equals 2 minus x squared? Anybody know? Zoe, you look like you know. What is it? It is a parabola. Which way is it then? Is it going to open, up or down? Down, and what kind of a shift? Good job. She's correct. So this is going to go up 2, and then it's going to open down. Now before we graph, let's go ahead and find some intercepts, just so we can make this real exact. Let's find our x-intercepts first this time. So to find my x-intercepts, I'm going to plug in 0 for x. I'm sorry, plug in 0 for y, I meant, and solve for x. So if I plug in 0 for y, the x squared comes over here. I get x squared equals 2. I take the square root, and I get plus or minus radical 2. So I have 2 x-intercepts. Radical 2 is about how much? 1.4. So I'm going to go out 1.4 this way and 1.4 this way. Looks like that. So there's the way it has to look. I can see my y-intercept. Our y-intercept has to be at 0, 2. As far as the symmetry goes, let's jot down no symmetry on this one, just for completion. On this one, we have symmetry with respect to which axis? Y-axis, yeah. You can just see it. And I just abbreviate it, symmetric with respect to WRT, y-axis. It doesn't say we have to find our domain and range, but just go ahead and jot that down. Negative infinity to infinity is our domain. What about the range there? Bobbin, what is it? And we'd have to have a bracket around the 2. Okay? Pretty easy, right? Okay, so we are in the book. I know most of you brought your book, but some of you may not have. If you did not bring your book, I want to show you what you need to get on your phone. You can just get the Canvas app, and I'll show you where everything is here. Oops, I'm just going to go back to the very beginning. So when you go to the Canvas app for the first time, you're going to see all your classes that you have. So you're just going to click on your class, Calculus. If you go to the modules, because usually I tell you to go to the calendar to find the solution keys, and that's the easiest place to go, is the calendar to find those. But if you want to find the actual book, you go to modules, and then you can either go here to textbook, or you can go to chapter P, which is what we're in now. I'll just go here. Oops, not there, anywhere but there. So I go to right here. We're in section P1. I'll always write that up there too. So you go to section P1, pull that up. And right here's the textbook. And you just scroll down to the end because this is just all the explanation in the textbook. And then right here is our page that we're doing. Okay, so you can either bring that up on your phone if you didn't bring your book. If you didn't bring your book and you don't have your phone or you don't have Canvas, you can just take a picture of somebody else's book. But make sure you get started on the homework now. Yeah. No, this will be our block day assignment. I forgot that it was block day. So just only the Tuesday assignment is what you need to do.